first question says solve the simultaneous equations. So for this, I'm going to use the substitution method. I'm going to substitute the first equation in the second one. So that means it's going to be 3 times 3y plus 6 times y equals to 24 minus 3y plus 6. That's going to give us 9y squared because 3 times 3y plus y, 3 times 3y times y is 9y squared plus 18y because 3 times 6 is 18 and 18 times y is 18y. Over it's going to be 24 minus 3y minus 6 because the negative sign gets distributed with both the terms inside the bracket. So now if you collect all of the terms on one side, 9y squared plus 18y minus 24 plus 3y plus 6 equals to 0, which is basically 9y squared plus 21y minus 18 equals to 0. All three terms are divisible by 3. So we can divide all of them by 3 to simplify the equation. So that's going to be 3y squared plus 7y minus 6. Now, if we factorize this, that's going to be 3y squared plus 9y minus 2y minus 6 equals to 0. Factor by grouping now, 3y squared plus 9y will be one group, and 2y and negative 6 will be another group. So in the first group, we have 3y common. So that's going to be y plus 9. And in the second group, we have negative 2 common. So that's going to be, in the first group, we have 3y common. So that's going to be y plus 3 in the bracket. And the second group, we have negative 2 common. So that's going to be y plus 3 again in the bracket. We take y plus 3 common, and the other bracket we'll have 3y minus 2. So that's your factorized version of this quadratic equation, which means y equals to negative 3 and y equals to 2 by 3. These are the two values of y. Now we need to find the corresponding values of x using the first equation. So if we use y equals to negative 3, that's going to be 3 times negative 3 plus 6, which is negative 9 plus 6, and that is negative 3. And if we use y equals to 2 by 3, that's going to be 3 times 2 by 3 plus 6. That's 2 plus 6, and that is 8. So when x is negative 3, y is also negative 3. When x is 8, y is 2 by 3. That is your answer. Next question says, write x squared plus 8x plus 17 in the form of x plus a whole square plus b. So you have to convert this quadratic equation to completing square form. We begin with checking if the coefficient of x squared is 1 or not. In this case, since the coefficient of x squared is 1, we can move on to the next step, which is dividing the b value. B is your coefficient of x by 2. So that's going to be 4. So once you've divided our b value by 2, we write x squared plus 8x plus square of 4 minus square of 4 plus 17. Since plus 4 square is a new term that we've introduced, we have to subtract it as well. That's why we wrote minus 4 square as well. This part of the equation into a plus b whole square. Because right now what we have is a square plus 2ab plus b square. But we need to write it as a plus b whole square. So we can see that our a value is x and b value is 4. So it's going to be x plus 4 whole square. The minus 4 square is going to be outside this bracket, so that's minus 16 plus 17, which can be rewritten as ax plus 4 whole square plus 1. We've converted the quadratic equation into the completing square form. Main step was to divide your coefficient of x by 2 and then square that value and add that value and subtract that value from the original equation. So once you've done that, you can just rewrite that as a plus b whole square for the main part, and the other values remain outside the bracket. Then it says find the coordinates of the turning point. Point of a quadratic equation is found using the completing square form. Completing square form over here is x plus 4 whole square plus 1. This is your x coordinate of the turning point and this is your y coordinate, which means turning point is -4 and 1. Now, reason why it's -4, not positive, because completing square form basically originally is x minus h whole square plus k. It's supposed to be x minus, not x plus. So in the case we have x plus, we always add a negative sign with the x coordinate. Y would be the same. If it was minus k, then it would be minus y. If it's plus k, it's going to be positive y. But for your x value of the turning point, remember, if it's not x minus, like, whatever the number is, then you will add a negative sign with the term. If it's x plus, then the number comes as it is. The next question says calculate the length of BC. So this is BC. So what I'm going to do is I'm going to divide the triangle, draw a line from C to A. So if we look at the triangle ACD, we can see that we have the two lengths and the angle between them, which means we can apply the cosine rule to find the length of AC. So that's going to be AC square equals to AD square plus CD square minus 2 times AC times CD times cos of angle D. So that's going to give us 7 square plus 14 square minus 2 times 7 times 14 times cos of 70. Plug it in the calculator and you should get AC square equals to 177.964. Now we take the square root of both sides, and that's going to be 13.34 centimeters. Now that we have AC, what we can do is we need to find one of the angles, because in the triangle ABC, we don't have any angles, we have two lengths. And in triangle CAD, we just have angle D. This angle A cannot be used for CAD because that's the complete angle for the quadrilateral ABCD. So to find this angle over here, I'm going to use sine rule because we have one complete set of angle and length, and we can use this set to find the missing angle over here. So it's going to be 13.34 over sine 70 equals to 14 over sine of angle CAD. So sine CAD is going to equal 14 times sine 70 divided by 13.34. So sine of angle CAD is going to 0.98618. Then we will take the inverse of that. So sine inverse of 0.98618 is going to be 80.46. That is your angle CAD. So which means if to find this angle, we will do for angle CAB, that's going to be 150 minus 80.46, which is going to be 69.54. So now that we have two sides and angle between it, we can find BC using cosine rule again. So I'm just going to do it over here. BC square equals to AB square plus CA square minus 2 times AB times CA cos of angle A. So plug in the values. So that's going to be 8 square plus 13.34 square minus 2 times 8 times 13.34 times cos of 69.54, and that's going to give us 167.35. Square root both sides, and BC will equal 12.94 centimeters. So as you can see, all the steps are connected. If you get one value wrong, your entire question will be incorrect. So you have to make sure that you just do this carefully step by step, find each of the missing values, and then reach your value of BC. The next question says, below is the speed time graph for the journey between two stops on a miniature locomotive. Work out an estimate for the acceleration of the locomotive at 20 seconds. So if we go from 20 seconds, to the graph, we can see that this is the line that we get. So what you will do is, you need to remember that the gradient of a speed time graph equals to acceleration. So if you find the gradient of this line, we can use that as an estimate for the value of acceleration at 20 seconds. So what I will do is I will pick one point over here and the next point over here. So you can easily find our rise over run. Rise is 2. So acceleration is going to be 2 over run is 20. Because you find the difference of 40 and 20, that's 20. So this is 2 over here. This is 20 over here, and this is 2. So that's going to be 1 over 10, which is 0.1 meter per second square. That is our acceleration. Then it says work out an estimate for the distance traveled by the locomotive during the journey. So for the distance, we basically need the area under the graph. So since it's a curve, it's not like a definite shape, so we can't find the exact area, but we can find an estimate. So for that, I'm going to divide the graph in different intervals. So now if we join this line, we can see that we have this triangle over here. And similarly, we have a triangle in the last portion as well. For these portions, we can see that we have 3 trapeziums. So we can find the area of 2 triangles and 3 trapeziums. And when we add that up, that gives us an estimate for the distance traveled by the locomotive during the journey. Once again, area under the graph for a speed time gives us the distance, and slope of a speed time gives us acceleration. So I'm going to call this A1, A2, A3, A4, and A5. So A1 will be, since it's a triangle, so area will be 1 over 2 times base times height, which is going to be 1 over 2. Base is 20, and height is 3. So that's going to be 30 meters. Then A2 is going to be 1 over 2 times the height times sum of parallel sides, so A plus B. Our height for this is 20, which is this. And parallel sides are 3 and 4.4. So times 3 plus 4.4, and that gives us 74 meters. Then for the third portion, A3, it's going to be 1 over 2. Height is 20 again, and parallel sides are 4.4 plus 4.2. That's going to give us 86. A4 is going to be 1 over 2 times 20 times 4.2 plus 2.4. That's going to be 66. And lastly, A5 is going to be 1 over 2 times 20 times 2.4, which is 24. So now for the distance, total distance, I will add these values. So that's going to be 30 plus 74 plus 86 plus 66 plus 24, which give us 280 meters. That is your estimate for the distance traveled by the locomotive during the journey. Once again, since it's an estimate, so we divide the shape into intervals. I took intervals of 20. Then I split these intervals into shapes that could be formed. The first and last interval make a triangle, and the middle three intervals make trapeziums. So then we find the area of the trapeziums and the individual triangles over here. And once we found those areas, we add them up and get the total distance.